All right, guys, this is day 1 of 3 days of practice before Mach 11. Today we're going to focus on all of the different solving methods that we've used. First, we're going to solve radical equations. Remember, with radical equations, you do need to check whether your solution is a solution, because we cannot have an even root of a negative number, nor can we have a square root give a negative number. First one, we're taking the square root of y minus 8 plus 5 equals 7. For any of these, you want to isolate the radical if you can. So the very first thing that I want to do is subtract 5 from both sides. I know it's weird with the choices below it, but we're going to subtract 5 from both sides. I'll do the rest of it here on the bottom. So that gives me the square root of y minus 8 equals 2. Now we want to undo the radical, so we're going to square both sides. That's going to undo the radical on the left, giving me y minus 8. 2 squared is 4. And then last step is to add 8 to both sides. All right, that gives me a y value of 12. Now, for the sake of time, if you plug 12 in, it does work. The solution is viable. Now, the second equation, it looks like we have 2 radicals on one side. However, we have 0 on the other. So if we move the second radical over to the right, we have a really nice situation. So I'm going to add the square root of 4w plus 5 to both sides. It's going to give me the square root of 5w plus 3 equals the square root of 4w plus 5. Now, this is a situation where we have a square root on the left equals a square root on the right. So essentially, if we're saying these things are equal and they're both already under square root, all we have to do is say that the 5w plus 3 must equal the 4w plus 5. Now it just becomes solving a linear equation. We've got to move the w's to one side, the constants to the other. I'm going to move the 4w to the left. I like keeping my variables constant if I can. And then I'm going to move the plus 3 over to the right by subtracting 3. That's going to give me w on the left equals 2. And again, for the sake of time, I did plug this in, and it is a viable solution. Now the third one is a little different from the first two in that you have a radical on one side and not a radical on the other. The radical is already isolated, so there's nothing to move. But what happens when we square both sides to undo that radical is that I'm going to get a quadratic on the right-hand side, which by now you guys know we're going to have to factor to solve. So when I square both sides on the left, I get 3n plus 10. The radical just goes away. On the right-hand side, if I expand this, remember it's n plus 4 times n plus 4. If I expand that, box method, whatever you guys want to do to multiply, on the right you get n squared plus 8n plus 16. Right now, to solve a quadratic, we know we have to set it equal to 0. So I'm going to move everything on the left to the right because that square on the right is already positive. So I'm going to subtract 3n from both sides, and I'm also going to subtract 10 from both sides. That gives me 0 on the left equals n squared plus 5n plus 6. The two numbers that multiply to give me 6 and add to give me 5 are positive 3 and positive 2, so I can rewrite this as n plus 3 times n plus 2. And remember, to solve, you set each of these factors equal to 0 and solve for n. Doing that gives me that n equals negative 3 and n equals negative 2. It does turn out that both of these work, so our correct solution is B, negative 2 and negative 3. And this is a very similar situation to the one we just had with number 3. I've got to square both sides to undo that radical. And when I do that, I'll get a quadratic on the right-hand side. So I've got 10 minus 13r equals r. I'm going to go ahead and expand it. Remember, this is r minus 4 times r minus 4. Expanding that gives me r squared minus 8r plus 16. Again, I need to get it set equal to 0, so I'm going to, now be careful, make sure you're subtracting, the R and the constant are in the reverse order, so make sure you're subtracting from the right thing. So I'm going to subtract 10 from both sides. I'm also going to add 13R to both sides. That gives me 0 on the left equals R squared plus 5R plus 6. Very similar factors. So this gives me 0 equals the two numbers that multiply to give me 6, add to give me 5 again, are positive 3 and positive 2. So that gives me R plus 3 times R plus 2. Tells me that R equals negative 3 and R equals negative 2. But this presents an interesting situation, because if you take both of these and you plug it back in here, you're going to end up getting that the square root of 10 minus 13R is going to give you a negative number, because when I plug in negative 3 here, that gives me negative 3 minus 4, which is negative 7. I'm not going to have a square root give me a negative value. Same thing is true here. When I plug in negative 2, I'm going to get that the square root gives me a negative number. Negative 2 minus 4 is negative 6. Neither one in this case work. So therefore, we're going to say that there is no solution. Now, it's been a bit since we've done solving with rational exponents. So I'm going to rewrite this equation at the bottom of the choices so it's easier to read. So I haven't really done anything yet. I'm just rewriting the problem. Now remember, with solving rational equations with rational exponents, these still are radical equation. It's just they're written as a rational exponent. And remember, to undo a rational exponent, you have to raise both sides to the reciprocal power once you get that term with the rational exponent isolated. So this is very much like solving for x, except I want to get this by itself so that I can then undo that 3/5. So the first thing that I'm going to do is move the 1. I'm going to subtract 1 from both sides. That gives me 3 times x plus 1 to the 3/5 equals 24. I still need to move that 3 in the front, so I'm going to divide both sides by 3. That gives me x plus 1 to the 3/5 equals 8. Now at this point I've isolated the rational exponent, I can undo it, and I do that by raising both sides to the reciprocal power. So I'm going to raise both of these sides to the 5/3. That cancels out the rational exponent on the left and gives me x plus 1. And then on the right, your calculator will do this for you. If you do 8 to the 5/3 in your calculator, it will tell you the answer. But I do want to see if you can reason through this. So remember, the bottom of the fraction is the root, the top is the power. So this is saying take the cube root of 8, which is 2, and then raise it to the 5th. If you take the cube root of 8, which is 2, and raise 2 to the 5th, you end up getting 32. And then I've got to subtract 1 from both sides. And that gives me that x is equal to 31, which is A. All right, similar situation here. I went ahead and rewrote it. We want to get the rational exponent by itself. So we're going to move that 10 first. We're going to subtract 10 from both sides. That gives me negative 64 equals negative times m minus 10 raised to the 3/2. Now, there is a negative in the front. That's basically a negative 1. We just don't write the 1. I still do need to take care of that. That is something that is in the way of us solving for that equation that has a rational exponent. So I'm going to divide both sides by negative 1. That's just going to make the left positive, so I get 64 equals m minus 10 to the 3/2. And once again, to undo that rational exponent, I'm raising both sides to the reciprocal power, so I'm raising both sides to the 2/3. So let's see if we can reason through this again. This is saying take the cube root of 64, which is 4, and then square it. So 4 squared is 16. So I've got 16 equals m minus 10. Last step is to add 10 to both sides. and I get m is equal to 26. All right, moving over to solving log and exponential equations, which was the next big type of function that we solved. Remember with these, this is fairly new or recent. We're going to convert between both forms in order to solve. So if it starts as a log equation, unless you're using a special property, you're going to end up turning it into an exponential to solve and vice versa. So in this first one, we've got log of 5x equals log of 2x plus 9. This one is actually really nice. It's sort of like the square root one we just did where they both had a square root on each side. In this case, I have log base 10 on both sides. So since we're saying they are equal, and the logs are already the same on both sides, all we really have to do is ensure that what's inside the log is the same. So we've got to make sure that 5x equals 2x plus 9. This is at this point just solving a linear equation, so I'm going to subtract 2x from both sides. And that's going to give me that 3x equals 9. Last step, divide by 3. And I get that x equals 3. All right, now the second one, we cannot use this property we just used for number 7 because I don't have the same log on both sides. So what I do have to make sure I do is get this log by itself so I can convert it. Just like before with the radicals, if there's anything that is keeping me from solving for that x within the log, I've got to move it first. So I'm going to divide both sides by -12 first, to move that -12 to the other side. All right, that's going to give me log of x minus 3 is equal to +2. Now the log is by itself. Also remember that if the base is not written, it is default base 10. So now I've got to convert. So I'm going to start with the base, go towards the equal sign. 10 raised to the second power equals x minus 3. Again, that's 10 to the second equals x minus 3. 10 to the second is 100 equals x minus 3. Last step, add 3 to both sides. So x is equal to 103. Now the properties that are true for logs or regular logs are also true for natural logs. So this is number 9 is no different from what we did with number 8. It's just now we're solving a natural log equation. Now notice this is a little slightly different in that we've got more than one log on a side. Even if I move the natural log of 4 to the right, that does not help me. So what I'm going to have to do is condense this. Whenever you have more than one log on a side, you will always have to condense before you can solve. Now remember, if there is a minus, if there is a difference of 2 logs, that means you have to rewrite it as a quotient. So if I rewrite this problem as a quotient, on the left I'm going to have ln of x minus 3 over 4. Oops, let's go back and make that a little prettier. Ln of x minus 3 over 4. And that equals 5. Now remember, ln has a default base of the natural base of e, which we need so that we can convert. All right, so I'm going to start with base e, go towards the equal sign. So e raised to the 5th equals x minus 3 over 4. Again, that's e raised to the 5th equals x minus 3 over 4. I'm going to multiply by 4 on both sides. We're solving for x. That's going to give me 4e to the 5th equals x minus 3. And the last step is to add 3 to both sides. Now, when you add 3 to the left, you're going to get 4e to the 5th plus 3. That is the exact answer. However, if you want the approximate answer, which is normally the way the choice is given, and if you look at our choices, they are the approximated answer in decimal form. If you put 4e to the 5th plus 3 in your calculator, you're going to get 596.7, which is C. All right, we don't have more than one log on a side, but we do need to isolate this log so we can solve. So I need to move that minus 7 over by adding 7 to both sides. It's going to give me log base 6 of 9 minus 7x equals 1. Now we convert, starting at the base towards the equal sign. 6 to the 1 equals 9 minus 7x. 6 to 1 is just 6. So 6 equals 9 minus 7x. All right, and I'm going to subtract 9 from both sides. You don't want to move the 6 because then you have nothing left on that side. Gives me negative 3 equals negative 7x. And then when I divide by negative 7, those negatives are going to cancel and become positive. So x is equal to 3 over 7, which is A. Now we're moving to exponentials with number 11, very similar to what we did with the logs and the radicals. If we can get the bases of the exponentials to be the same on either side, all we really have to worry about is that the exponents aren't the same. So in this one, we can say that 3 minus 2x must equal to negative x. Again, it's just solving for a linear equation. So I'm going to add 2x to both sides. That's going to give me 3 equals x, and that's it. I'm done. X is equal to 3. All right, we also learned a property that like I just stated, if you can get the bases to be the same, you just have to worry about the exponents. Now, in this one, it doesn't look like the bases are the same. However, I can rewrite 81 as a base of 3. I can leave 3 to the 3x minus 2 alone because it's already a base of 3, and I can rewrite 81 as 3 to the 4th. Now we have a very similar situation as we had here. The bases are the same, so all we have to worry about is that 3x minus 2 equals 4. Add 2 to both sides. It gives me 3x equals 6. Divide by 3. And that gives me that x must be 2. Now, we are going to split this into 2 videos just for the sake of the video length. So stay tuned for the second part of the equations practice, which will be numbers 13 through 20.